Now today we'll be looking at the volume of prisms. So I'd like you to write down that heading, volume of prisms, and today's date. So first of all, volume. Volume is just the amount of space occupied by your 3D shape or solid. Now another way of saying that is we are looking at how many unit cubes we can fit into that 3D shape. Now the unit that we use for volumes are called cubic units. For example, cubic meters or cubic centimeters, etc. So using that basic definition of volume, let's have a look at this first example, which is a rectangular prism. So we can have a look at how many unit cubes fit into this rectangular prism to figure out the volume for that prism. So at the bottom, we have 3 cubes, and we have 4 lots of 3 cubes. And so we can say the volume starts off with 3 by 4 cubes, which is 12 cubes. And at the top, we have the same amount of cubes. Okay, and so we are doubling the volume there. And so the total number of cubes would be 24. Okay, and because each cubes are in centimeters, okay, we can say the volume for that prism is 24 cubic centimeters. Okay, so let's look specifically at the formula that we can derive for the volumes of any prisms. Okay, so first of all, let's remind ourselves of what prisms are. So remember, prisms are 3D shapes that have uniform cross sections along its length. So I've provided some examples here from our everyday life. So if you have a look at a slice of bread, if I cut across, okay, this way, okay, I get a cross section that are pretty much the same shape and the same size. And so we can say that this loaf of bread is a prism or a prism shape. The same goes for this cucumber. If I cut it along its length, okay, I get the same shape. And so this is like a prism. Now, when you have recognized that your solid is a prism, you can use the formula V equals to A times H to find the volume, where A is the area of your cross-section, and H is the depth or the height of your solid. So in this example here, we have a triangular prism. The cross-section is a triangle, so we need to find the area of this triangle, which becomes the A. And the height would be the depth or the height of my prism here. And so if I find those two values, all I need to do is multiply those together to find your volume for that prism. Okay, so let's have a look at a few examples. So the first example, we want to find the volume of this pentagonal prism. Okay, and so if we have a look, it's a pentagonal prism because no matter where I cut along the length of this prism or this solid, I get a pentagonal shape, and it's the same size pentagon. All right, so you would write down the volume formula after you recognize it's a prism. Okay, and then you find your area and your height. Okay, in this case, we are given the area, it's 8 square meters, and the height is 12 meters. Okay, now one thing you need to note before you substitute that into the volume formula is that the units must be the same. So the units for area and the height must be the same. Because for example, if I had square meters, but my height was in centimeters, it wouldn't make sense if I multiply that together. I'll get square meters, centimeters, which is not a unit for volume. So remember, the unit for volumes are cubic over unit, so cubic centimeters or cubic meters. So we need to make sure that the units are consistent before we substitute that into your formula. In this case, they're the same, and so we just substitute those in as it is. Okay, so remember, between the A and the H, there's an assumed times sign there. All right, so we can put that in. And so we're doing A, which is 8, times the height, which is 12. So the volume is 12 times 8, which is 96 cubic meters. And that's your answer. Let's have a look at the next example. We have a triangular prism here. So as you can see, if we cut along the length of this solid, you'll be able to see cross sections of triangles. So because we've confirmed that the cross sections are the same, we can conclude it's a prism, and so we can use the formula for finding the volume of the prism. So the volume is A times H. Now in this case, we are not given the area, and so we're going to find the area of our cross section. So the shape of our cross section is a triangle, and we know that the area of a triangle is half times base times height. All right, in this case, the base is the 10 at the bottom. Height is the perpendicular height, which is given as 6 here. So we substitute that into the formula, half times 10 times 6. Okay, that will give us 30 square meters. Okay, so we substitute that into our volume formula for A. Okay, that's 30 times the height, which is 15 meters. And I can directly substitute those in because both the height and the area has units involving meters. And so I do that multiplication by substituting that into your calculator. You should get 450 cubic meters, and that is your volume. Now the next question is, we want to find the volume of a rectangular prism with the dimensions 9 meters by 4 meters and a depth of 3 meters. So in this case, we are not given a diagram, so we need to draw one. So here we have a rectangle base, which is 9 by 4. Okay, 9 meters by 4 meters. And the depth is, we're told it's 3 meters. And then so it goes in 3 meters. Okay, so after you drawing your diagram, you can identify where your cross-sectional area is. And I know this is the cross-sectional area because if I cut along this length of this rectangular prism, I'm going to get the same cross sections as the shape at the front. Okay, so let's first write down our volume formula. V is equal to A times H. The area in this case is the area of a rectangle, and we know the area formula for rectangle, it's base times height. Let's change that to base times length so that we don't get confused with the height in the prism formula. So base times length of the rectangle, that's 4 by 9. So you write that down, 4 times 9, which is 36 square meters. We now then take that and substitute that into a volume formula. And so we get 36 times the height of the prism, which is 3 meters. And that should give us 108 cubic meters. And you can do that calculation on your calculator. The last question is this solid. So I'm going to first check that it's a prism. You can see that if I cut along this length here, okay, can you imagine what kind of shape I'll be getting? It's in fact this shape at the bottom here. And we know what that shape is. It's the trapezium. So this is a trapezoidal prism. Okay, so I'm going to shade that area because that's the cross-sectional area I want to use in my volume formula. So V is equal to A times H. The area here is the area of a trapezium, and we have learned the formula for that. It's half times A plus B times the height, which is a different height to the height in the volume formula. Don't get that confused. A half times, remember A and the B is the length at the top and the bottom, or the parallel sides of your trapezium. So we know the bottom, that's 10. The top here, as you can see, is the same length as the length at the back here. If I can write that down, that length is 6 centimeters. And so in the brackets, I'll be adding that value with a 10 at the bottom, and then multiplying it by the perpendicular height of the trapezium, which is 5 in this case. Alright, so if we multiply those together, you should get 40 square centimeters. And again, we substitute that back into our formula for A, and then multiply that with the height of the prism, which is 12 in this case. So we put that in, substitute that in, and we, on our calculator, calculate 40 times 12, should give us 480 cubic centimeters. And that's our volume for this trapezoidal prism. Let's do a quick recap of how we find the volume of prisms. Before you do anything, you've got to first check that your solid is a prism first, because otherwise you won't be able to use that formula. Right? And you can check that it's a prism by looking at its cross sections. And so if, in this case, if we cut through this triangular prism, in this way, you'll be able to see that the cross sections have the same shape as the shape at the front of the solid. As soon as you identify that it's a prism, you can then start writing down the volume formula, which is A times H, where A is the area of the cross section and the height is the depth of your solid. Alright, so I hope everything made sense today. If you have any questions, leave a comment in Google Classrooms, or you can email me for if you need further clarification on anything. But for now, I would like you to go into MathSpace and work on the volume tasks that I've set. Okay, and that's due tomorrow. If you have any questions again, let me know. Also, if you have any overdue MathSpace homework tasks, I would like you to finish that as well today. Thanks for tuning in, E9. I would like you to make sure all of this is copied down into your book, take a photo of it, and upload it onto Google Classroom for me. Take care, and I will see you next lesson.